welcome to Tech to Tech presented by KYZEN, where we will explore common cleaning questions and answers. Let's get started. I'd like to introduce KYZEN's own Jody Saultz.
Thanks, William. Thanks for joining today's Tech to Tech presented by KYZEN. We're going to focus a little bit on a case study for Underside white cleaning that was done with one of our contract manufacturers. And I call this the overlooked process because I think that Underside stencil white cleaning is probably the most overlooked process in the whole production line, which can probably cause you the most issues. But we was given this opportunity to use our chemistry in a automotive project down in Mexico, and they're using a competitive chemistry right now that's very strong in odor, very volatile, and they are basically getting 2 prints out of this cleaning process right now. So they're wanting to optimize that as well. They want to replace the chemistry, like I said, and they're having a ton of defects. So the bad part about it is they're basically just scrapping out these boards and throwing them in the trash instead of trying to fix the issues. So we stepped in and tried to help them. They was having a lot of voids and inefficiencies that were all detected through SPI. So like I said, they give us the opportunity to run a trial on their printer. They was using, like most CMs, they try to go cheap. So they was using a cheaper paper, and they was using basically every 2 hours, they was using 2 rolls of paper. And the parameters they was using were a wet vac dry. I don't necessarily like the wet vac dry. I like to end with a vacuum, but this customer wanted to do a head-to-head with the newer chemistry, so we stayed with the exact same parameters. They're processing about 1,500 PCBs a day, 3 shifts with about 40 failures. And like I said, they're basically just scrapping these boards out, throwing them away, which is costing them a ton of money. Even the cost savings that they're going to get just from changing to the KYZEN E5631J was huge compared to what they're using. We almost cut their cost savings in half just by changing them over. So if you look at the challenges that the customer is having, like I said, they're looking for an alternative, and they want to replace this competitive solvent. They want to reduce the failures and the scrap of the PCBs, and then they want to improve the cleaning process and yields. And they want to reduce the cost of chemistry and other consumables, such as chemistry, paper, wipes, and in some cases, even paste, because they're having all these defects and they're scrapping the boards out. So they're basically throwing away a lot of paste as well. So when a chemistry isn't performing well, typically there's a lot of reasons why. You could have a broken or bad delivery system, wrong chemistry selection, or the printer may not be set up correctly. 90% of users never change default settings, so they never optimize the system to get the best efficient piece of equipment working the way it needs to be to optimize their process. So if you look at the process, this is just a quick image of the printer they're using along with the PCB. The printing process, when you change over from an older chemistry or an existing chemistry to a newer chemistry, it's always best if you remove or purge all the fluid out of the system, whether it's in the holding container, the line going from the container to the nozzles, the hose, the nozzles themselves. It's good to make sure you get all that out there. And then you can add the E5631J and then purge the system again. Make sure that the E5631J is being dispensed. So you can make sure that you have flushed all the old fluid out of there. And then basically what we did is we run a test with a couple PCBs with the existing customers' parameters. Like I said, they wanted to stick with the same exact parameters. So we ran 4 test PCBs, and in the end, we actually got to 6 prints, which we'll kind of go through their process here. So the printing process that they're currently doing right now, they are cleaning every 2 prints, which is more than likely the default settings with this printer. They're using a wet vac dry, and then also they're doing 45 millimeters a second on the cleaning speed, 55 millimeters on the dry cleaning speed, and then the vacuum is set at 50 millimeters. We didn't change any of those parameters in the beginning. We stuck with the parameters just so the customer can get a comparison. But like I said, we eventually went from 2 to 3 to 4 to up to 6. Is where they're actually running with the E5631J. So these are just some images that were taken throughout the testing. This is with the competitive chemistry, and this is even just after the two boards being printed. You can see that the apertures and the stencils are coated with a paste, so it was never really even cleaned out. So I would say a lot of their defects are coming just from this paste not being cleaned out, and then they process the next board and they have issues. So we stepped in with the 5631J. We did 3 printed boards. You can see that the competitive solvent basically still has paste inside the apertures, and the E5631J, the apertures are clean. So we kept running through the process. We basically processed 31 boards, doing every 2 boards in their cleaning cycles with the E5631J. If you can look at some of the data at the bottom, total PCBs 31. We had 1 warning, which was a wiper blade issue, which has since been fixed, but it was causing warnings just about every time we would print. And then we stepped from 31 to 45 boards. You can see 100%. Everything came out good with the E5631J after 3 boards being processed and the cleaning process taking place afterwards. And then 72 boards, same thing. We went to every 4 boards with the E5631J. The 72 boards, like I said, all these boards were good, but the warning that the machine was actually getting was caused from a wiper blade issue, which they did since have fixed, and all that's been taken care of now. So conclusion, like I said, this customer was scrapping out all these boards every day. They was just basically throwing them in the trash. It was wasted components, the FR4 board, the paste. They was having 40 or 50 defects per day, which was costing them a ton of money. So after pretty much our 8-hour test we did on the one shift, they printed almost 500 boards. They had no defects, and only 13 warnings. So they was very ecstatic over the results that they had. At the end of the day, we actually increased to 6 prints, which they're currently running right now. And we told them that even with the parameters that they had set forth and the paper that they was using, that you could probably get some further optimization out of the machine by going to a better printer paper, and also changing some of the current speeds and delivery system um, speeds for the paper itself. So they was very excited about that. Um, you could see from the results in the presentation that they had excellent results on the SPI data, and we're going to continue doing testing with those to see if we can't get them from 6 to 8 to 10 to maybe even 12 prints before they have to run the cleaning cycle, which is going to save them a lot of money. And it's going to guarantee that the stencil's clean. And basically, as of right now, this machine is running flawlessly, defect-free, and the customer is very ecstatic with the performance of the E5631J. So some of the frequently asked questions on this topic, how do paper rolls save you money? There's many different type of paper rolls out there. You have cheaper ones versus more expensive ones. Some are very coarse, some aren't. I like the coarser ones because they seem to capture the paste a little bit better. But do your homework, do your testing, even though paper is a little bit more expensive, when you can optimize the machine and get 6 to 8 to 10 to even 12 prints, you can afford to use the higher dollar paper and still save you money in the long run. Number 2, is 5631J compatible with nanocoating? The answer to that is absolutely. Don't be worried about nanocoated stencils. This chemistry is compatible with no issues. Does the nozzle type affect how the cleaning agent is dispensed onto the paper? Absolutely. All these printers have different delivery systems through their nozzles or bar feeders for the paper. The most important part, no matter what kind of printer that you have, is to ensure that you have 15 to 20 millimeters wetting on the paper after the nozzles have been turned on. That 15 to 20 millimeter, we've done a ton of testing, seems to be the most optimal parameter for wetting of the paper. So absolutely every nozzle type for every different machine can have an effect on how the fluid is dispensed on the paper. And is there a cost associated, if you use a savings for IPA? Everybody thinks IPA is the greatest thing ever. In most cases, it doesn't solubilize all of the paste out there. So that's probably why a lot of customers are printing and cleaning after every 2 or 3 boards. And then also it has an odor to it as well, and it is very flammable. So I don't like using the IPA. Very unsafe. But there is a huge cost savings if you actually use an engineered chemistry and get rid of the IPA and all the safety that's associated with that. And with that, I'll turn it back over to William.
Thank you, Jody, and thank you all for watching this Tech to Tech session. If you would like to discuss this topic further or have any questions not answered in the session, please contact your local KYZEN regional manager or send an email to tech@kyzen.com, and we will have someone follow up with you as soon as possible. To download the case study this session was based on, click the link in the description. Do you want to have exclusive access to future content sent directly to your inbox, or do you know someone who'd benefit from these sessions? If the answer is yes, just go to tech2tech.kyzen.com and fill out the subscription form. And if you like this video, be sure to follow us on our social media platforms for more expert cleaning content.